Okay, today we are going to begin looking at section 3.2, which are graphs of functions. You're going to be able to determine either an x or a y value at a certain spot, and you're going to be able to express the domain and the range in interval notation. You're going to be able to tell whether a graph represents a function or if it does not. Based on a graph.
Yeah.
So if you look at this first picture right here, and I know it's difficult to read, copied it from the book. What you should see here is a closed circle, and by the way, this is 8. Sorry. 8, and then you should see this is an open circle. Do you know what an open circle represents?
A hole.
It's a hole, good. Now over here is a hole, and then we have a closed circle here at 7. So this is a piecewise function. It is a function. It passes the vertical line test. If I ask you to evaluate this function at a couple places, for example, if I say evaluate for f of 0, what does this 0 represent, the x or the y value?
The x.
The x. So if you were to go to 0 on your x-axis, what's the output? What's that number right there? Whoops.
Good try, Regina.
What's that number? 7. So what's f of 0? It is 7. What do you think f of 3 is? Where x is 3, y would be 0.
That's right.
Easy?
Is it Regina?
Yeah.
Okay, the next thing.
Here's the flyer.
If I ask you to express the domain of this function, the domain is all of the x values. Now look at the x values. What's the small, we always read a graph left to right. What's the smallest x value?
-8.
-8. Now let's see if it goes all the way down to, what's the biggest x
doesn't.
value? 7.
It doesn't consecutively.
It doesn't. What is it skipping?
It's at 2,
At 2. We have a hole here and here.
so it's -8.
So go ahead. Nick, do you think you have it?
You do have to put it in.
Yep.
So
Negative?
yeah, -8, and then comma 2 parentheses,
Good job.
and was it union?
Yep.
And then it's 2, 2. What is it?
I think it's 7. Is it
Yeah,
7?
7.
Should we put a bracket or a bracket?
Bracket.
Good job. Perfect. Okay, how about the range? The range is the up and down. Always start from the small, what's the smallest y value? Yep, -9. Should we use a bracket or parentheses? Bracket. Okay, and now this is going all the way up to, now we do have a hole here, but there's not a hole here, so we're clear on that, -2. We're good. Same with, if we keep going, see how we're going up? The y values are all covered all the way up to what y value?
7. 8. Oh, just kidding.
8. So was that difficult? So can you guys all analyze functions and determine what the y value is given a certain x value and then be able to write the domain and the range? So for homework, you're going to do these 8 problems.
Is that it?
These, not done yet. These 4 go with this graph, and these 4 go with that graph. This is what you're going to work on in a minute. There's another way to determine whether a graph represents a function, and that's by doing the vertical line test. And I know you guys have done the vertical line test several times. You guys are actually really good at this. How do you know whether a graph is a function? Here's 2 relations. One is a function and one is not. Based on the vertical line test, which one's not?
Left one.
The left one. Why? Explain why.
If it is a function, you should be able to go on any x value and only hit like one line. You should never pass more than one point.
So this one passes that vertical line test. This one does not. It's not a function. Why is this one not, if I asked you why is it not a function? Well, for example, this ordered pair is, this could be 4, comma 2, and this is 4, negative 2. So we have an x value that's repeating, so it's not unique. Questions? You guys know the vertical line test. To test whether or not a relation is a function given a graph, simply draw a vertical line through the graph. If it hits the graph in only one spot, it is a function. We've done several of these. So the other part of your homework is these 6 graphs. You're going to draw vertical lines through them and analyze them and tell me whether they're functions or not, yes or no. The next thing you're going to do, example 6, we're going to graph a piecewise function. Now yesterday, this is what we did, if you remember. You were given a function, a piecewise function, and we asked you to do something like this. What's f of 3? Well, 3 is in which line? Is it in this? Are the x values less than or equal to 1? You use that, x squared. If the x values are between 1, not including 1, if it's including 1, you use the top one. Between 1 and 4, you use the bottom one. So what would I put 3 in? Would I put it in this, is it 9 or is it 5?
It's 5.
Why?
Because 3 falls between 1 and 4.
So 3 plus 2 is 5. What if I said f of negative 3? What would you give me?
Use 9.
Negative 3 squared is 9. What if I said f of 5?
No solution.
It's no solution, it's not defined. The domain, the only possible numbers that we can use, our domain is negative infinity to 4. That's it. These are all the only numbers that we can use for x. So this is our domain. Now, how do you graph this piecewise function, like problem number 1? There's 2 ways you can look at this, and I don't care which way you do it, just pick which way is easiest for you and stick with it. Here's one of 2 ways. I want you to look at this, there's two equations here. This one is y equals x squared. How do you graph y equals x squared? It's a parabola. If someone said graph y equals x squared, you start at the origin, over 1 up 1, over 2 up 4, and over 3 up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? So if we were to sketch a graph of this, this is the parabola. This is y equals x squared. But we have a problem. We only want y equals x squared for all the x values that are less than or equal to 1. Well, where is 1 on this line right here? Right there. So can you tell me the part that's less than or equal to 1?
Left.
It's this right here. Tell me if you understand this. And you stop there.
Because it's equal to.
So what do I do with this other part? Remove it. This function does not exist for numbers that are greater than 1. So you erase it. Now, look at the next equation. It says y equals x plus 2. How do you graph y equals x plus 2? You begin at 2 and you go up 1 over 1. Easy graphs. And you go like this, right? This is the graph. But according to our restrictions, I only want the x values that are less than or equal to 4, but greater than 1. So tell me where we have between 1 and 4. Right here. Here's 1, 2, 3, 4. So I'm going to go right here, and anything greater than 4, I have to erase. And anything less than 1, I have to erase. And then there's a hole at one,
Yeah.
thank you. So we have a hole at one, and then we have a closed circle. That's the graph of this piecewise function. Now, it is a function, right? We use that fancy notation. Does this pass the vertical line test?
Yes.
Yes. If we would have used the parabola and that line, you know it wouldn't be a function, right? Now, check out this. This is the one thing I want to make sure you understand. Everybody see where the hole is here and then the closed circle? That passes the vertical line test. If you were to draw a vertical line through here, it's only hitting in one spot. Now, how would you write the domain of this? What is the domain of this function?
Negative, or yeah, parentheses, negative infinity.
Negative infinity to what?
Comma 1.
Oh.
Oh yeah, 4. Right.
That's your domain.
Oh, just kidding.
How would you write the range?
Y is greater than 3 equals 0.
0 to infinity. Okay.
Do you
All
want
right,
it,
now, I
do you
told
want
you
it-
guys there was 2 ways to do this. Yeah.
Do you want it as 0 to infinity, or Y, or like, do you want it?
You can write the range. Whoops, this would be a bracket. 0 to infinity.
So you want it like that.
D and R. D for domain, R for range. Or you could write X, some people will use an X. And then Y. Okay, here's another way you could do this problem. Check out this first equation. It says Y equals X squared. I only want X values that are less than or equal to 1. So if I asked you to make a table, give me numbers that are less than or equal to 1. 1, 0, negative 1. Now, if you plug these numbers in here, what's 1 squared? 0 squared, negative 1 squared, negative 2 squared, negative 3 squared. So guess what these points are? 1, 1, 0, 0, negative 1, 1, negative 2, 4, negative 3, 9. Now, why don't I have 2 in here? Because that's not part of this domain.
And it's gotta be equals to equal to
Now, what about the second function? F of x is equal to x plus 2.
2, 3, and 4.
So what numbers, I'm going to first put 1, then 2, then 3, then 4. Make sure you do that number. But make sure when you plot that point, it's an open circle, not a closed circle. So if you were to put 1 in here, 1 plus 2 is 3. 2 plus 2 is 4. 3 plus 2 is 5, and 4 plus 2 is 6. So guess what we have here? 1, 3. Over 1 up 3, we put an open circle. Why do we have an open circle? Because it's not including 1. 2, 4, 3, 5, and 4, 6. Now, which way do you like better? Do you like the erasing it, or do you like the table?
I feel like I should do it in my head.
Okay, it's totally up to you. I will give you these tables if it will help you. If you don't need them, you don't need to use them. It's all up to you. Okay, so if you flip the page, 41 through 44 are all piecewise functions. I did not draw the table. If you need the table, go ahead and do it. Put it in there for you. Okay, now last problem and I'm done. The absolute value function can be written as a piecewise function. Do you guys remember what the absolute value looks like? It's a V. So if I gave you this problem, what is this graph to be?
The letter
The V, at the origin, right?
Yeah.
Okay, now, do you understand that this is really 2 lines?
Yes.
This is this line right here. Can you give me the equation of this line right here?
X.
It'd be y equals x plus, we'll write plus 0. You don't need that plus 0.
But what they did is they got rid of the second half, so you gotta figure out how they did
What's the other equation? What's this equation right here? Y equals negative x. Now, am I using positive x for all x values? No, I'm only using this piece if the x value, if x is greater than or equal to 0. Here's 0. And I'm using this equation, y equals negative x, if the x values are less than 0.
Could it have been x, like the first one, just greater than the last one, less than or equal to? Do you know what I mean?
Yes.
Would it have
Did
been
everybody hear what Nick said? He's saying, I think this is what you're saying, could I have put a greater than here
Yeah.
and then greater than or less than or equal to?
Would it
Yes.
have mattered?
Just put the equal to sign on one of them.
Alright.
Now, how would you write this as one function? You make your bracket, and then instead of these two y's, you're going to write f of x equals. So let's do another one. Let's do another one. And you're going to see a pattern. How do you graph y equals x plus 3?
You shift the graph over left 3 and then V to V using x1.
You're going to shift your graph 3 to the left.
That's your B value, yeah? Right?
Now, does anyone know what these two equations are? What's this line right here? Does anyone know what this one's gonna be? This is gonna be y equals what kind of x? Negative x minus 3, yep, yep.
You did good.
Now,
You did good.
how would we write this as a piecewise function? You're gonna write f of x equals, and then here's your bracket. Let's start with this one. X plus 3, if the x value is greater than or equal to, what's this number? Negative 3. And what's this equation?
Negative x minus 3 if x is less than negative 3.
Yep. Now, look at this equation and see if you see a pattern here.
That you're going to carry over whatever is in the equation to your y-intercept.
What's one? One is positive, and what's the other one? Think of distributing a negative. Now watch this one. This is different. What if it said, how do you graph that
You're
one?
going to shift it up 3.
Up 3.
So you, what is it D value? Damn.
Okay, can you tell me what these two equation names are? What's this one? What's this equation called?
X plus
Y equals
absolutely
x plus 3. But when did we use this one? For the x values that are, what's this number right here? Greater than or equal to 0. What's this equation name?
negative x plus 3 when x is less than 0.
When x, you got it, less than 0. So how would we put this in one as a piecewise? F of x is equal to x plus 3 if x is greater than or equal to 0, and negative x plus 3 if x is less than 0.
So the
Now,
final answer is written out with if and
yes, those are the ifs. Now check this out. What did we change in these two equations?
instead of putting an absolute value, you just split it up into 2 columns like you do on the
Yes.
equation.
But look at this 3. Did the 3 change?
No, because it's on the
How-
outside of the absolute value.
Yes, good job. Why did it change here?
It's on, that's a B value
The
now.
whole thing is in the absolute value. So if you want to draw it out like I did, I don't care. If you want to remember the shortcut, I don't care, as long as you can express it as a piecewise function. Yes.
To the bottom part, do we just put that in? No,
What do you mean?
to the one on the bottom.
Yes.
Correct?
So this is just an example of this. So we could do this, we'll do one together, 45. It's saying absolute value of x plus 2. I gave you a little graph here. You can graph it if you want. What's the graph? It looks like this. So how would you write this in two pieces? You're going to write f of x equals, can you tell me what one of the equations is? X plus 2. If x greater than or equal to 0, and what's the other equation? Negative x plus 2 if x is less than, I didn't write the word if, but
Okay.
write that.
Do we need to write the word if, or can we just comma, whatever?
Do you think you guys have this?
Yeah.
Okay, you have the rest of the time to work on this assignment or 3.1.
I don't even know. Okay, no, we do that.